Hey guys, so today we're going to be talking about the planets, the 8 major planets in the solar system. So we're not counting Pluto, we're not counting Ceres, and obviously we're not counting the Sun or the Moon. Now we've talked about most of these, or we've talked about all of these in your presentations, so we're only going to go briefly through each planet. But what I want you guys to do is to draw a table that looks something like this. So have planet down this left-hand side, and then I want you to have the length of a day, the length of a year, and the axial tilt. Now we're going to go through what all of those mean. So the day length of a planet is the time it takes for it to spin around on its own axis once. So basically, if you had, where'd my marker go? If you had a planet right here, then a day is the time it takes for it to spin around like this on its axis one time. The length of a year is that if you have a star here and a planet over here, the length of a year is the time it takes for the planet to loop around the star and come back to its original starting position. And axial tilt is a little bit weird. Axial tilt is, well, it's the tilt of the axis of the planet. So I'm going to just draw a diagram to explain what that means. Now, this right here would be like the North Pole, and this down here, the South Pole. So if it's rotating like that, and the North Pole and South Pole are straight up and down, this would be a 0-degree axial tilt. Now, if it's tilted a little bit to the side, whoops. If it's tilted a little bit to the side, like something like that, then it wouldn't rotate like this anymore. It would rotate kind of like that now. So it would rotate at some angle. So instead of spinning like this, it would now spin like this. So that's a different rotation. So if this is straight up and down, then this right here would be the angle of rotation. So we could call that like 30 degrees or whatever. So that would be like a 30-degree rotation. Now, for those of you who've spent a little bit of time working with degrees and stuff in math, then you'll notice that 180 degrees means the same thing as 0 degrees, except rotating in the opposite direction. So you could say that this planet has an axial tilt of 0. You could say that this planet has an axial tilt of 180 degrees, or 0 degrees retrograde. And retrograde means just in the other direction. So basically, if you were all running in a circle counterclockwise, and then one of you decides, you know what, I'm not going to run counterclockwise, I'm going to run clockwise, then you would be said to be having, or to be moving in retrograde motion. So that would be, so 0 degrees retrograde is the same as 180. So basically, some of the planets are effectively upside down, is basically what I'm trying to say. So, we're going to go through all the planets. Make sure you have enough rows that you can write down all the planets. So we'll start off by writing in the names of the planets. So we've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So we've got 8 planets. We're going to talk about the day length, the year length, and the axial tilt. I'm going to mention a couple of other things, maybe something that makes a specific planet unique, or something that we still don't know about a certain planet. But because of your astronomy presentations, I'm not going to write anything about it because we spent 2 whole classes talking about that stuff. Anything that I don't write here, I'll say I won't test anything that I don't write here, because it's already a bit of a weird system that we got going on, a little bit of a weird situation with these videos, and I'm not there to answer questions, so I'll only test you on stuff that I write on the board. So when it comes time for me to make the final exam, I'm going to rewatch these videos and only test you on things that are written up here. Okay? So, we're going to start off by talking about Mercury. Mercury is the closest planet to the Sun, which hopefully we all know. These are all obviously ordered in order from closest to the sun to farthest from the sun. Now the day length on Mercury, so the length of a day on Mercury is 59 Earth days. So that's the time it takes for the planet Mercury to just spin around once like that on its axis. So that's a long time. That's basically 2 months. So 59, Earth can complete 59 of those rotations in the time it takes for Mercury to complete one. So basically the day length here, this day is the length of a day on a given planet. This day means Earth days. So 59 of our days, our Earth days, is how long it would take for one day to pass on Mercury. Now the length of a year on Mercury is much, much shorter than the length of a year on Earth. And the length of a year on Mercury is only 88 days. So that's pretty short when you think about it. 88 days is just shy of 3 months, or about a quarter of a year. So basically, for me being 20 years old on Earth, I would be 80 years old on Mercury, because for every 1 Earth year, Mercury is able to go around 4 times. So the year length on Mercury is much, much shorter. And the axial tilt of Mercury, it's pretty much 0. I think it's a smidge off that, but it's not off by very much. So it's essentially 0. It basically spins like this. So not too complicated. Mercury doesn't have any moons. It's got a little bit of an atmosphere, but it's a pretty thin one. And it's made mostly of metal and silicates, which I believe we talked a little bit about in somebody's presentation, whoever presented on Mercury. Alright, next up, our next planet on this list is Venus, which, as you all know, is the second planet from the solar system, but it's also the hottest planet. Now, the reason it's the hottest planet is that it has a really, really thick atmosphere. Some of you may have heard of the greenhouse effect on Earth, where you've got gases like carbon dioxide and methane and things like that that are in the atmosphere that trap the sun's heat. Now, Venus is basically Earth, but with a runaway greenhouse effect. So it's a similar size, it's a similar, density. People used to call Venus, some people do still call Venus Earth's twin, because of the similar size and gravitational pull and all that. But compared to here, Venus is much more like hell. It's really hot, it's really hostile. Not much could live there. It would take a lot of work for something to manage to survive there. So Venus actually has such a thick atmosphere that if you were to try and stand on the surface of Venus, you would actually be crushed by its atmosphere. So our bodies are built to withstand the entire weight of our atmosphere, but just once, right? Earth's atmosphere, but nothing on top of that. Venus's atmosphere is so dense that if you were standing on the surface, the pressure from that atmosphere above you would be 92 times. 92 times more than the pressure on Earth. So you would effectively just be crushed. Your body would be subjected to 92 times the pressure that it's used to. So that's a fun fact about Venus. So the day length on Venus, this is a little bit weird. So Venus's day, if you thought 59 days was long, get a load of this. Venus's day is 243 Earth days long. So that's, well over half a year. So Venus rotates on its own axis extremely slowly. So slowly, in fact, that it's longer than it takes for it to go around the sun. It goes around the sun in 225 days, and then still takes another 20 days on top of that to finish one rotation. Now, its axial tilt is also a little bit weird. So it's got the year length is fairly normal. It's longer than Mercury's, but shorter than Earth's. Cool. Its day length is incredibly long, and its axial tilt is also weird. So its axial tilt is 177 degrees. Now, if 180 means it's basically up and down, but spinning in the opposite direction, 177 degrees means it's not quite straight up and down. It's off by just a little bit, by just 3 degrees here and 3 degrees here. So it's only off by a little bit, but it's spinning in the wrong direction. It's spinning that way. So not only does it take more than half a year to spin around once, it's doing it wrong. It's doing it in the wrong direction. But yeah, so you could say that it's 177 degrees, that its axial tilt is 177 degrees, which means it looks like that and rotating the wrong way. Or you could say it's 3 degrees retrograde because it's rotating in the wrong direction. Okay, next one is Earth, obviously, third planet from the Sun. Now, the day length on Earth, I could say 1 day. I'm going to be a bit more specific. It's most people will say, okay, if you want it in something other than days, then it's 24 hours. It is a little bit off from 24 hours. An Earth day is 23 hours, 56 minutes, and 4 seconds. So that's effectively 24 hours. The time it takes for Earth to spin around once is 23 hours and 56 minutes and 4 seconds. But then it's also moved a little bit more in its orbit, so the Sun is in a slightly different position in the sky, and once you kind of work through that sort of scenario in your head, that Earth has spun around once but it's moved a little bit in its orbit, then in order for the Sun to actually return to the same spot in the sky, it takes a few extra minutes, and that's what we effectively see as 24 hours. Now the length of a year on Earth, again, I could say it's 1 year, but I'm going to go with the other way to write this. The common way is 365 and a quarter, or 0.2526-ish days. So it's just over 365 days. This 0.26 is the reason that we have leap years every 4 years. So this 0.26, if you add it on, you get 365 and a quarter. And then you get another 365, so that's 730 and a half. And if you do that 4 times, then you end up with this extra day on the end of it. So that's why we have leap years every 4th year. Now, it's not exactly 0.25, as you can see. So eventually it does get out of sync. But our calendar system currently is good enough that it only goes out of sync by about 1 day every like 8,000 years or something. So we're good. And the axial tilt of Earth, we know it very precisely, but I'm going to give it to you with less decimals than we know. It is 23.4 degrees. So it's not a particularly extreme axial tilt, but this axial tilt, this number is important because it's the reason why we have seasons. Now obviously here in the Dominican Republic, the seasons don't assert themselves so much. Summer is a little bit hotter, a little bit more humid, but in a place like Canada, you can really tell the difference between whether your part of the planet is pointing towards the Sun or really far away from the Sun. So axial tilt is important for Earth. If it was much, much greater, if it was something like 90 degrees, that would mean our planet would be sideways, and you'd basically have 6 months of darkness for an entire hemisphere of the planet. Parts of the planet do have that kind of daylight pattern, but those regions of the planet are difficult to live in, like Antarctica. So it would be bad news for an entire half of the planet to be going through that. All right, next planet is Mars. So it's actually quite similar to Earth in terms of its day length and in terms of its axial tilt. So its day length is actually only 24.5 hours. So it's not that much longer than Earth. It's about, I think it's, 2.7% longer than an Earth day. So scientists that work on things like Mars rovers and stuff, they'll actually get watches that run 2.7% slower. So basically their body clocks, the clocks that they live by, they essentially run according to Mars time because that's what their work requires them to do. So their schedule, their entire day is just half an hour longer because their watches all run slow. Now the length of a year on Mars, if you can sort of see the pattern that we're getting, these year lengths are getting significantly longer. So the length of a year on Mars is 687 Earth days, which is just shy of 2 years. And it causes a little bit of a problem with trying to send rovers, and once we get people on Mars, it'll be a bit of a problem because Earth is going to be so far away from Mars for some parts of the orbit that that's a challenge that needs to be overcome. And the axial tilt, I did say it was very similar. It's 25 degrees. So seasons, and now, I mean, all of Mars is colder, but the seasons do exist in some form because of that axial tilt. Mars also has 2 small moons. I didn't really mention Earth has a moon because we all know that. But Mars has 2 small moons that are both like potato-shaped. So they're not large and spherical like our moon. And Mars is actually believed to have had liquid water on its surface at some point. There's evidence that liquid water used to be there. There's evidence that suggests it could be there now. But whether it has life right now is the real question. It does have polar ice caps the way Earth does, which contain water ice. So it is promising in terms of travel there. And parts of the environment aren't that different. The length of a day and the assertion of the seasons are probably not too different from how they are on Earth. I'm sort of running over time right now, so I'm going to stop this one. We'll pick up with the outer planets in part 2.